All right, welcome everyone. Today we're going to be solving the problem of the most common letter. This is just a string manipulation problem, right? We have to find a letter that is not a space. So we have to find a character within a sentence that is the most common. So it's saying always lowercase and it should appear in 2 words or less, or it could appear in 2 words or less. All right, that's great, and replace it with the letter that's being provided in the function. So we get the example here of my mom loves me as never did. So obviously M would be the most common letter in this. And we can see that by replacing it with a T. So we see T, T-O-T, and then T again. But it's also important to note E appears quite a bit, right? So we have 1, 2, 3, and 4 different instances of E, while M appears only 4 times as well. So both of them are appearing 4 times. So then how did this decide to only replace the M instead of the E? Well, we can see here if such letters are 2 or more, choose the one that appears in the string earlier. So the string also matters where it falls within the string, right? So both M and E are present a total of 4 times, but because M comes before E in the string, it replaced M. Then we have real talk bro, which I'm assuming the A, nope, looks like, so we have R and R, A and A, and L and L, which are happening all twice, but it decides to replace the letter R because it's the first one that populates. So Neil talk, B and O. And then we have great job, go ahead with the K. So here it looks like the letter to be replaced is A. And that makes sense because A is actually the highest occurring value. All right. So things to consider as far as edge cases, right? We have to, one, consider, it looks like we have to keep a count of how many times each letter appears. And we should also keep in the back of our heads, when was the first time that the first instance of this letter appeared as well, right? So we have to keep track of both of those, preferably in one single iteration. Can anyone think of any edge cases, or does anyone have any questions regarding this problem?
Would a edge case just, I guess limit the input?
What do you mean by limit the input?
That way, like if it doesn't equal like a regex almost, like if it's not within the alphabet or something, then just return not an alphabet.
Got it. So like
Like
checking.
a not a letter or something. Check in whatever argument is trying to be passed through.
Okay, awesome. So we could have something to account for characters. I believe in this example, we're being guaranteed that we will always receive a series of characters, all in lowercase letters. So that's a good thing to think about, but I don't think it applies to this example. What other?
Will we also just make sure we can lowercase everything? That way we receive data the same way.
Oh, so
Are
that's
you saying that same thing?
yeah. So what I'm saying is that the problem is guaranteeing us that we will always receive it. But that is something that we could kind of keep in the back of our minds, right? Is hey, maybe I
Think
probably make sure that everything in the string is lower. All right. What else?
um I don't know if this is jumping ahead, but we can take um every we can separate every letter and then we can compare it to the other letters to see how many times it's in the string, and if it appears more than once we can store um that string somewhere else. I'm not sure. I remember I think we did this in one of the pre-courses.
Okay, so upon iteration, store count and index of string or of letter.
Of the probably of the letter. I'm not sure.
Okay, of letter within string. Okay, great. What kind of data structures could we utilize to store this information?
A dictionary.
Ah, a dictionary. Why are you choosing a dictionary over a list or tuples or any of the other different data structures?
Well, this way here we can use we can take advantage of the what was it, the key value pair. And the value would just be how many times a letter occurs, while the key is the letter itself.
Okay, let's take a look at that. So we're saying that we would want to essentially build a dictionary where the letter would be the value, or excuse me, the key, and the count would be the number of occurrences. Is that correct?
Correct.
Okay. So that is one way that we could implement this. I guess my next question would be, if I'm keeping my count of occurrences, how will I know which letter came first? Because as of right now, I'm storing all my letters, their count, inside of a dictionary, but I don't know how many times or when were they populated, when was the first time that it appeared within the string? Where would I store that value? Or should I handle that separately?
Do you just put everything as 0 first? Or I guess put a variable that makes it equal 0?
Okay, so you're saying have a separate outside variable named index and set that to 0?
I think we're looking for count, right? Count first, because if not, I think we would just do a, what is it? A loop that loops through the string, and then from there it'll count each and every instance and add it to the dictionary.
Okay, so we have our string, right? And our string has multiple letters. That's more than enough letters. All right. And what you're saying is, as we're going to iterate through the string from left to right, only one time, preferably. Right, so one iteration preferred. And what we're saying is, as we're iterating through this string, we are going to build this dictionary. So for example, if the letter L was not present in the dictionary, we would add it into the
Yeah.
dictionary. And then
Yep.
as an occurrence of
With an add up count of 1.
that's great. And what happens if L and L are both present and O are present, and then the rest are just random letters, right? Then at that point, we would have two key value pairs where L would have the value of 2 and O would have the value of 2. How would I then decide out of these two letters which one should be replaced?
You might be able to get the lesser index of which one ever had the lesser index, and then get rid of the other one. I'm not,
I see. So you're saying write a comparison such as
yeah,
maybe if a letter or maybe sentence dot index of letter is less than sentence dot
Dot.
index. Oh, go ahead.
yeah.
Of letter 2, then replace letter. Something like that.
Or yeah, letter something, letter equals replace, yeah.
Okay. Yeah, this is definitely a great starting point, and I think we have the majority of the pseudocode that we need to be able to solve this. The one thing that I would like to emphasize to everyone is functions like index or replace or any functions that seem like they're iterating through the string in order to find a specific value under the hood, they're doing just that. They're doing multiple iterations, right? So when you're running something like index letter and then index letter 2, you're essentially iterating through the string twice. So important to keep that in mind when you're working within data structures and algorithms, all right? That will definitely go in part with your efficiency. So let me go ahead and share this problem here on the chat one more time. I'm gonna pass it on the Zoom chat. Everyone should have access to it. If you click on that, it will populate it. I'm gonna go ahead and stop the recording, open up the rooms, and for 10 minutes, talk as a team and see how you can solve this problem. All right, welcome back, everyone. I was watching some of the groups go through their problem solving. That was great. Some fantastic stuff. I definitely think that the way that I'm going to solve this is going to be through 2 iterations rather than 1. I know that I said that 1 would be preferred. So I'm going to go with 2 iterations first, and then afterwards I'll try to refactor and see if I could do it with just 1 iteration. So I'm going to go off our pseudocode here. First, I'm going to go ahead and PyTest. Let me comment out the majority of these because right now the one that I care about is that this works. I'm going to PyTest test.py. All right, so test.py works. Everything's being imported correctly. And now I'm going to go ahead and try to solve the remaining of these problems. So just like we talked about, we definitely want to have some sort of dictionary. So here I'm going to create a letter dictionary. And I'm just going to save it as a dictionary. And then what I'm going to do is I'm going to iterate through the sentence. I'm going to enumerate, so I have both the index and the letter. And then I'm going to ask if the letter is in letter dictionary as a key, then all I'm going to do is have letter dictionary with the key of letter and the key of count be plus or equals 1. Otherwise, if it is not inside of my current dictionary, then I'm going to build it by adding the letter and setting this to another dictionary where I will have a count of 1, and I will have the index representing the initial instance where it occurred. So this way I can capture both the index and the amount of letters in there. So let's go ahead and print our letter dictionary just so we could see it at work. And I'm actually going to comment out the majority of these just to start off. I'm just going to tackle down this first one. So let's go ahead and run PyTest, test.py. All right, so PyTest at test.py, here's my captured output. And I'm going to try to move this a bit. We can see that I have the letter M. It tells me the count, the number of indexes. I have all the letters accounted for, but I am noticing a small discrepancy here where I'm also accounting for empty spaces. Definitely not something that I want to do. So I am going to add that as an if statement here. So what I'm going to do is I'm going to add this as an else if and say if letter dot strip is not equal to an empty list, then I will do so. And let me run that real quick. All right, so now my dictionary populates and it is not accounting for empty spaces. So now I have my counts, the indexes where it appeared, and my dictionary is working pretty well. Okay, great. So now I'm going to go ahead and select a letter. So let's do selected letter. I'm just going to make that equal to none for now. And now we'll iterate through my dictionary. So for E in letter dict, if not selected letter, then I'm just going to make selected letter be equal to P letter dict E. And then I believe this one is going to be IDX. And I believe we also have our count, which should be letter dictionary, key, count. All right, so that's in the case that if there's not something already selected, it will set it as the default. All right, so now, else if letter dict key, and then I want to check the count is greater than or equal to the selected letter count. Now I have a couple of edge cases here. Maybe I should run a greater than first and then handle the version where it's equal to as its own independent instance. And I'm actually just going to copy this here, right? Because in that case, I would want to overwrite my selected letter with the current value that I'm on. Okay, so that's if it's greater than. Well, what if it's equal? Is equal to selected letter count. Well, if it's equal to it, then I care about the index. And letter dict key IDX is less than selected letter IDX. Then I can copy and paste this one last time. Okay, so that will give me my selected letter. And let's make sure that that is the case. We'll knock out of our for loop here and print the selected letter. This is a bunch of code that could definitely be refactored, so that is okay. Let's see what it gives us. All right, so I'm getting an error here. Unindented. Oh, yep, that's my fault. All right, so it seems like it can't identify count in this else if statement. So letter dictionary key count. I do have it as count. Huh. Interesting. Let's see what error I've made here.
It wouldn't be simply because you got on line 16 right there, count is in single quotes, but all the rest of your counts are in double quotes, would it?
No, I don't think so. Let me check this print statement here. If I got any captured output, it seems like I didn't. I just got this none. So something else is happening here. So if none, selected letter is equal to key. Where is the count coming from? So it seems like the error is happening on line 16. Huh. You know what? I may just simplify my life here to see what is going on.
You need to add commas.
Where?
After you have key and count, comma, no, maybe mistaken.
Let me try this out real quick. Oh, where am I typing? I was typing somewhere. Hopefully I didn't. Okay, so it is in fact giving me that error, but let me see what the error is here. Okay, 0116. Replace colon elif letter dictionary key count is greater than selected letter count. So it is being spelled the same everywhere. So it's not a simple spelling error. Oh, I know what it is. So if selected letter is not none, and I believe that's going to be the issue. And I was wrong. All right.
I think it's because selected letter is a dictionary of key to another dictionary, which does count as a key. Because you're storing like here you're storing a dictionary of a key to another dictionary, which has a count as a dictionary. Did that
Well,
make sense?
right now it's selected to none, right? Yeah, it shows up as none. This is where we get our trace back.
Okay.
The problem is
I'm just saying, like before, when you call selected letter of count, like down here, you would have to call like selected letter of key of count because it's like a dictionary within a dictionary, I think. I might be wrong, but
oh, I see what you're saying. Yeah, I definitely think I messed that up. Let me try to run this real quick. I think that's a separate issue, but I do think it's an issue. Yeah, so there it is. No, it's not. Where's this?
Isn't it supposed to be dot keys or dot items or something like that when you're iterating through it?
If you iterate through the dictionary, it still returns just the keys. It's telling me that I have unhashable type dictionary and
I
replace.
think it's because you have two curly braces. Like you have one here and another here.
Gotcha. There it
There
is.
you go.
All right, so now we're getting count to 4 and IDX. So it is in fact giving me the one with the highest value, but we did lose the letter itself, so that's a problem. But we can do is we can now return the st dot replace and then pass st at index of selected letter IDX, which I believe is our key, with the letter itself. And now if we run it, we still get false. So let's see what we're actually returning here. Hopefully I'm not eating too much into your TA times. I apologize, TAs. So I'm getting DI, DOD, loves at index 0 and replacing it with letter. Oh, I see the issue there. There it is. So now it's returning true. I was using the wrong letter variable. All right. Well, I definitely got a little bit nested and lost within all of my loops of my rebuilding of dictionaries. So there's a huge opportunity for refactoring. I could probably just utilize a function or a helper function to do this for me. But now you can see I was able to capture the letter that I needed to replace, and I was actually able to replace it with the correct letter. But now let's actually see it in practice. Let's ensure that this is actually working by testing it against all of our other test cases. Let's see, PyTest, test.py. Ooh, and it looks like I passed 2 of our tests, but I failed 2 of them, which is rough. Great job. Go ahead, letter K. So it looks like I'm getting an error on count. So that might be what you were referencing to there, Brian, where I'm not accessing by the key. And it looks like I'm getting the same error on the other one. So there's definitely some room for improvement inside of this nested loop as to how I'm saving information or how information is getting stored. All right, everyone. Unfortunately, we are out of time, and I don't want to take up too much of our TA time. I'll keep debugging this, and once I get a solution, I'll pass it out to everyone. But that is our replace for a common letter of the day. All right, does anyone have any questions over the code that we just put together right now? Okay, great. If there aren't any questions, I'm going to go ahead and stop the recording.